We should be online. So, quick sound check. Can you hear me?
I can hear you. Can you hear me?
Can the rest of the stream hear us? Good. Yes, they can hear us. Cool. Then, then let's start. So, welcome to our monthly .NET meetup. First, thank you all for joining today. We have over 200 registrations for today, so this is really amazing for us. Short, this meetup is presented to you by the .NET Devs Austria. We are a non-profit organization whose purpose is to spread knowledge and experience about the .NET technology stack. You can find more information on our website. Where's my mouse? Here, and we are we are on Twitter, Twitch, as you see, on YouTube. So if you see this now as a recording, please leave a like and subscribe. And we have also our own Slack channel. I post the links of this all in the chat. If I can find the chat. Here they are. I also want to thank our sponsors who make it possible that we have these meetups, these monthly meetups. And this is first here to every, Rubicon, and JetBrains. JetBrains is sponsoring a 12-month license per meetup, which will be raffled. And for that, please fill out the feedback form at the end of the talk. Let's have some quick news from the community before Ian has his talk. So first, as half of you know, this meetup is part of the .NET virtual user group of the .NET Foundation, which promotes various virtual .NET meetups around the world. So if you want to join meetups around the world, this is your place to be. Join there, and then you get a lot of meetups for various topics. Here are the links. Good. And also some interesting events in the near future, mostly interesting for Austria. So on the 13th of November, there's the Virtual Global Microsoft 365 Developer Bootcamp Austria edition. And on the 26th of November, there's the Unity meetup happening. Also, there are some free workshops from Microsoft in the next weeks for various topics, and you get these also as links in the chat. So, but now to the reason why we are all here. This time we welcome Ian Cooper as our speaker. He's a polyglot coding architect in London, founder of the London user group, speaker, tabletop gamer and geek, tattooed, pierced and bearded. And he's the gaff on Brighter Command. So, Ian, please let us know what is the clean architecture and how can we build one in .NET?
Right. Thanks very much. Let me see. I should be sharing the screen. Should you guys see my slides, hopefully?
Yeah, they're on screen.
Great. Thanks very much. All right. So, yeah, I'd like to talk to you about clean architecture and how we implement that in .NET. So I used to talk a few years ago about a architecture from Alistair Coburn called ports and adapters, or sometimes also known as the hexagonal architecture. And I talked about it particularly with respect to test-driven development and how I found it was very useful in my practice of doing TDD. And the clean architecture is a modern take on that same idea, but really focused much more on a number of similar architectures and combining them together. Oops. This is me. There's nothing that interesting there, apart to say that I have some grey in my beard. I always call out the last point. I really got into speaking by accident because when I started the London.NET user group in 2002, I was a C++ developer. There's an exciting thing called .NET. There were no experts who could come to our meetups and talk to us about anything, so we had to do it ourselves. We almost literally would, take a volunteer to present something at the next meetup. And so I got over that hurdle of having to speak in front of people. And then I found it was really useful. It helped me. We have a kind of idea in English called see one, do one, teach one as a way of acquiring knowledge. And I found it very useful to learn to have to present about an idea that I was interested in order to make sure I was clear about how it worked. So I'd recommend it all to you just in terms of your own career. But also, back in the days before the pandemic, we used to say, oh, it's great. You get to travel the world and go to exciting places and meet different people in conferences. You don't get to do that anymore, but it's still quite entertaining. All right. I work on open source project called Brighter. We will talk about Brighter later on tonight. So I'll park further explanation. But what we would like to say is we hope we are a very friendly open source project. We are always looking for new people to come and join us. I always say the first thing you can do is go and read our docs, find everything that's broken since the last new person joined and read our docs, raise some issues, and then that will be a good way of you learning, us getting those fixed, and then you can get kind of involved in more stuff in the project. All right, what we're going to talk about tonight. So we're going to talk a little bit about layers because clean architecture is a layered architecture. What I want to do is review layers a bit because they've come into a bit of disfavor from popular developers on Slack, and I want to explain what they're for and why they are still very valuable. Then we'll talk a little about domains and how we organize domains, particularly with respect to layers, and as we begin to think about that organization of domain models, we get into some ideas, ports and adapters, boundaries, controllers, and entities that eventually lead us to the next section, clean architecture. This idea from Bob Martin, the synthesis of all those ideas. And then we'll talk a little bit about how, again, we can implement that in .NET. And I'll show you an example of taking a .NET application from something that has everything in the controller for an API to something that uses a much clearer strategy. Okay. And then afterwards, I'll talk to you a little bit more about Brighter and kind of how that works as a kind of bonus material. Okay, so Bob Martin noticed that a number of people had come up with a similar architectural style. Alistair Coburn had created this thing called ports and adapters, or hexagonal architecture. Jeffrey Palermo independently created something called the onion architecture, which is reasonably well known in the .NET space. And perhaps less well known to most of us, Ivar Jakobsen, famous for use cases in particular, had created something called boundaries, controllers, and entities. Now, you don't have to go away and read Bob's book, and it's not. I don't think that's the greatest book he's ever written. There is a blog post on his, which contains most of the details about what clean architecture is, and you can use that as just a simple summary. And I cover most of the material here. I know that Bob's a more controversial figure nowadays, and some of you may feel uncomfortable with giving him eyeballs, but his blog post is not going to generate revenue for him if that's your concern. Right. Okay, let's talk about layers. So layers, as I say, have fallen into a bit of disfavor. You see people talking about saying, oh, layered architectures are, kind of an anti-pattern almost, and I want to do vertical slices instead. We'll talk about that, vertical slices in particular a bit later. But I wanted to go back to talk about layers because they do have a lot of value, and I think some of that's forgotten. So the classic layered architecture looks a bit like this. And the idea is that we have layers that sit on top of each other. So the wedding cake with its individual tiered layers is often seen as a metaphor for this. So at the top I have my UI, often sometimes called the presentation layer, because in something that's simply serving an HTTP API, that would be the top layer, that HTTP API. Below that, I have the domain, and the domain is really where I get work done. It is the model of the business that I am building my application for. And then below that, we have infrastructure, sometimes also called the data layer, where we tend to talk to the database, doing a kind of I/O to file systems or event middleware, or even talk to third parties like payment gateways, etc. Where we do a lot of the I/O that we need to do to represent our service. And there are a couple of essential ideas you want to understand. The first is that the idea behind layers is to reduce coupling. So within each layer, we tend to use what's called a facade as a very coarse-grained API over that layer. We then hide from other layers a lot of the detail of that layer. So here my domain might have a coarse-grained interface which says, hey, the presentation layer doesn't need to understand all of the classes that go up to make given operations. It can just essentially call my much more coarse-grained interface. And in the same way, when I call my infrastructure to say save stuff to the database, I don't have to necessarily deal with the individual SDK wrapping that particular type of data store. I may have some more coarse-grained abstraction which just says, save your entity state away to the database. And that gives us a couple of things. It makes it much easier to reason about our software. If I'm working at the presentation layer, it's much easier for me to reason about these coarse-grained interfaces that come from below, or again from the infrastructure layer, to reason about this coarse-grained interface to saving my data, not the individual aspects of the SDK that I'm using. It also makes it possible for us to swap implementations out. And that makes it possible, for example, for us to say, well, that piece of infrastructure is difficult or expensive to use all the time, for example, for testing. So maybe I could replace that with something that can stub that out for the purpose of testing. And it also allows us to think about deferring decisions. We might want to say, well, we could start by modeling our domain, and then we can think about maybe exposing that via a UI. But for the time being, we can stub out our infrastructure, and then we can learn more about what we actually want to put in place. And I've used this in the past, for example, where I worked in an organization where we were building something that needed to have a document repository. There were ongoing negotiations from at a purchasing level with various vendors like IBM about what document repository we should buy. And we were able to keep the project moving forward by simply using an abstraction of a simple fake that we wrote using a database and the file system. So that decision could get deferred, and later on, once the actual contract had been agreed, we could basically implement that particular interface in terms of the third-party thing that we'd chosen to purchase. And I know a lot of people say, oh, I never swapped out a database. Why would I want to have a coarse-grained interface hiding away my database? The reality is, I find that interesting. Most places I've worked, I've changed databases for a large number of things at least once. But even more importantly, that I've often changed the framework that I used to wrap that data store. So I may have moved from nhibernate to DAP. I moved from a big fat ORM to say a micro ORM. I may have moved away completely from a relational store and taken my code that was, say, in Microsoft SQL Server and moved it into DynamoDB on Amazon, because actually it turned out my use case was much better for document databases in that case. So I've often seen this change. And if that infrastructure wraps things like a payment provider, well, you may have multiple payment providers you deal with. You may decide that the payment provider you're dealing with today is not one you want to deal with tomorrow. So actually, I find change is more common than some of the opponents of this model like to propose. But even if there was really no actual change of the implementation, the ability to hide those details is very powerful. And indeed, if we look at object orientation itself, it's really focused around that idea of saying, I want to hide implementation details away from the more coarse-grained interface. I want to hide the state of this object and just give you a way of manipulating it. Modules themselves as a concept really speak to that whole idea as well. So this is a really common idea in software, this idea of abstracting behind a more coarse-grained interface. The other thing to understand is dependency direction. So what we say here is that we always depend downwards. Okay, and this is what's called a relaxed style we're showing here. In this style, essentially, our presentation layer can talk directly to our infrastructure layer and not use a domain. Some implementations say are unrelaxed. It's impossible for our infrastructure layer to talk directly to our presentation layer to talk directly to infrastructure. It must go to the domain, right? Those are less prevalent now, post the days of ideas like CQRS, where it became quite common to have queries talk to the infrastructure layer. It's much more common to see a relaxed style. But I can go downwards, but I can't go upwards. Why not? Because that represents a cyclic dependency. If I have a cyclic dependency, if I need to basically make a change in C, and that results in a change in A, because I change, for example, the interface, which one do I build first? All right. And so we try and avoid those cyclic dependencies by having a rule saying we have to depend in one direction. All right. We'll come back. There's a workaround for that, and we'll come back to that a bit later. Okay. So a bit of a review of those statements. We can reason about a layer as a coherent whole. We can substitute layers with alternate implementations. We can defer decisions about layer implementations. And we can minimize the dependencies between the layers. Okay, that's why we use layering. Okay. And two key ideas are really at work when we talk about layering. And those two key ideas are pretty essential to writing software that's highly maintainable. One is coupling. And coupling is this idea that because I've made a change in module A, I'm going to have to make a change in module B, or at least retest module B. Okay. If we can reduce the coupling, we can reduce the impact of making changes. And indeed, an idea like refactoring says I can change my implementation details without changing my public interface. And I can, if I've got good modularization, then essentially I won't need to change the things that depend on the public interface because the implementation details alone have changed. Right? And so you can see that for one of those layers, I change the implementation details, but not the facade to that layer, then those other layers don't need to basically be rebuilt. And cohesion is the property that module is subject to the same forces of change. What do we mean by that? We mean that if I want to change something like, for example, let's say I'm writing a software that's shipping, and I ship cargo between two locations, and I have some variables about that cargo. You know, is it basically hazardous? Is it liquid? Is it dry bulk goods, etc.? And that may affect what ships I can choose. I've got information about the ships, and I've got information about the ports and destination. I may have a domain model that really understands all that. Okay. And I probably want most of those ideas about calculating my shipping route to be in one module. Because if I wanted to change some of those parameters, I wanted to change to close off certain routes because they were too dangerous for me to ship through, I'd want to be able to go to my module that calculated shipping routes and change it there, not go to a different module altogether. And I've worked previously in the past in places where there was poor cohesion between modules, and we literally had this kind of recipe for change where it was pinned to a wall, where in order to get one of these changes done, you have to touch these 6 or 7 modules. Sometimes it's called shotgun surgery, right? So cohesion stops this idea of shotgun surgery. It says, given that I'm making a change to the way we do X, I probably should find one module that handles X. Okay. When we talk about that domain layer, that layer in the middle, we can tend to distinguish 2 different types of things we're going to have in there. The first is domain logic, right, which essentially says it's solely to do with how the domain works. It's how I calculate the shortest path to ship my package. I want to calculate your insurance premium. So I want to figure out that what your current age is. Do you smoke? Do you ride a motorcycle? Do you go climbing at weekends for a hobby? What are your risks? And I want to calculate what insurance premium I should charge you. And that's really purely to do with the rules that our business has. And application logic, which tends to be, I need to orchestrate some things that provide my domain model in order to produce an answer to a question. Okay. Sometimes that logic includes things which manage our interaction with the infrastructure. So a typical case here might be, I want to essentially calculate a new insurance premium for you. Here are some parameters to do that. And the first thing you might want to do is go away and load some data from a database that gives you For example, a set of tables that let you calculate from various factors what premium I'm going to charge. And then having come up with a set of potential premium options with coverage, I might want to save that result for this customer into a database so it can be accessed in future. And then having created that, maybe I want to notify another system about those particular offers that I'm making by raising an event over some message-oriented middleware. And all of those actions of me talking to infrastructure as part of that operation are part of my application logic or my workflow logic that I'm actually doing in my domain. So that tends to give us a model which actually looks a bit more like this, right? We have some kind of UI or presentation layer. We have a domain layer that's divided into these two kind of parts, a service layer and an entity layer, where the service layer contains the application workflow logic, and the entity layer contains entities which are state and the behavior that is dependent upon that state, right? So if I have a class that essentially says, I am a ship in my entity layer, it has information I want to know about the ship. Is it a container? Can it carry liquid cargoes, etc.? And behavior that depends upon that state. So the things, the operations that depend on what type of ship it is. Okay. And then again, the infrastructure layer. One of the interesting things to note here as an aside is although we have 3 layers here, well, 4 and 4 once we divide that domain layer, is these particular groupings are convention, right? It's quite conventional that a lot of business applications tend to have a presentation tier, an infrastructure tier, and a domain we can divide like this. But there's nothing to say we couldn't have 30, 40 layers if it made sense to us. And indeed, if you go and look at ideas like domain-driven design, DDD quite often talks about having a layered domain. So we could actually imagine, even in our entity layer, having different layers saying, I've got a coarse-grained kind of abstraction in here over some more detailed stuff that I'm hiding below because my domain model actually looks like that, right? So the number of layers here is not fixed. You could have any number of layers that you feel makes sense for you. Typically, 3 layers will definitely get you started. And I would tend to look towards, creating more layers in that domain model because I clearly could see that was going to create simplification. Okay. Right. 2 basic implementation variations on that service layer. One is called the domain facade. So the domain facade essentially is very thin, and it just says, I'm just doing the application workflow logic, and nearly all of the work exists in my domain model. And I may even have what's called a domain service in there. And the domain service is some kind of plain old C# object that coordinates some of my entities, and doesn't have any technology concerns wrapping around it. But even it's taking some of the actual workflow logic of the domain about interacting with various entities from me. So my facade is very, very thin. The second option is what we tend to call an operation script. And that says that really my domain doesn't do my domain model doesn't have very much apart from creating and saving data. It's very CRUD based. Now CRUD based, truly CRUD based domains are actually, I think, a lot rarer than people think. It tends to be that when you get down to it, you will find that you do have behaviors associated with the state on classes. But in other cases, you genuinely do have something which pretty much says, I don't do very much apart from get one of these out, show it to the customer and put one back in again, right? So maybe I do something that says I store some important reference data. For example, I may store information about users in my system when I pretty much only have their phone number, their address, and their name. Other systems do stuff with it, but there's not much actual domain logic around any of those pieces. Right? And in that case, I can use what's called an operation script. I have these dumb objects, and most of my logic really lives in my service layer itself. Okay. And it's okay, actually, to have both in an application. It's okay to have different service layers, implementations, depending on what you're doing inside a given system. And that becomes even more clear when we get into some of the ways we can implement a clean architecture. So we'll come back to that later. Okay. there's this common idea, yeah, effectively having basically a class which is called ends in service, has loads of static methods in it. Those static methods have basically most of the operation script, and they deal with these very anemic data structures. Okay, so that's kind of like almost, layering as it's existed across time. So ports and adapters from Alistair Cockburn was an attempt to move that idea forward a little bit. And ports and adapters, Alistair Cockburn divided it into 3 layers. The first one's quite confusingly named. It's the application, right? The application layer in ports and adapters means the domain layer. It's a really bad naming choice because as a result, a lot of people think that when we talk about the ports being outside the application, we mean outside an app, in the term that you and I might think of an app as a process that's running somewhere that gives us some functionality. In fact, Cockburn doesn't mean that. Cockburn means the domain model, right? So the domain model, effectively, which Cockburn calls the application, is this kind of center layer. On the very outside, we have adapters, and adapters essentially say we want to get something into our application, some kind of input. We may want to receive output from our application, and our application may want to talk to secondary devices where it says, I want to read something from you, or I want to write something to you. Okay, those are adapters. They have to sit between us and that I/O, and then ports. The ports are are the intermediaries between an adapter and the application or domain model. They are purposeful conversations, as Cockburn says. And the idea of port was simply that there's some kind of layer with a coarse-grained interface into which different adapters can plug, right? So I can have multiple ways of driving my port. And that becomes clear when we look at this classical diagram of what port adapters architecture. And the reason it's called hexagonal is because traditionally it's drawn this way with multiple sides. And the reason it's drawn with sides is because Cockburn's idea was you can see these sides as particular types of plugs. So here you can see in the center, we have our application layer, our domain model, and those circles that, if you like, represent entities in our domain model, in our application layer. Outside that, the outer kind of ring, where you can see user side, notifications, database, and feed, those are the adapters. So on the user side, we have an HTTP adapter and a GUI adapter, right? So the idea is maybe we've got something that says I expose an HTTP interface for web API, but I've also got Razor pages there. And they're talking to my entity model via this port, which we'll describe more in a second. But I also might have, say, an Atom feed that I expose, talking about changes in my application. I might have notifications via AMQ, Peter Rabbit MQ, or to Azure Service Bus, or I might have a WebSockets adapter where essentially I talk to via SignalR to something, or I might talk to email via SMS, right? I may, very probably in a non-trivial application, read and write stuff to database, right? And I have the adapter wrapped over that. And those adapters are things that essentially let our entity model in the center talk to the outside world. And these adapters don't talk directly to the entities. They talk through that inner line, the port. And the port says, you as an adapter plugin, call me, and you use me to exercise the entities. And I'm a coarse-grained interface over that entity model. So you can see there this idea from Cockburn, the adapter layer, the port, and the application layer in between. Now, interestingly, it's just a different variation of layered architecture. And it's a layered architecture that really has a model which says depend inwards. We depend from the outside, the adapter, through the port to the entity model in the center. And it's not a relaxed architecture. We must effectively go through the port. Although it's relaxed in the sense that I can go from the adapter to the port to another adapter if I need to. So we can model it a bit like this. Taking our original kind of layered infrastructure model, we can say we've got an adapter layer which sits on top of a port layer, which sits on top of the application layer. And mirroring back the existing sort of 3-tiered layer structure we looked at, infrastructure and UI have both become this adapter layer. That's one of the key differences. They're both in this outer layer rather than infrastructure and presentation or UI being top and bottom, right? They're both in this outer adapter layer. Then essentially our domain layer again is split between port, which is really effectively our old service layer, and application, which is essentially where our entities now live. Okay. And you can see this model which kind of says, okay, it depends inwards. In our case, we can show that it's depending downwards, right? Now here we'll talk about this interesting idea which says, we talked about the service layer being the thing that's likely to mediate some of our conversation to, say, the database or messaging middleware. And we can see in this model here, that's essentially an adapter, right? So down notifications, AMQP adapter, that'd be messaging middleware for raising notification that our insurance premium has been calculated. Database adapt would be where we save that, right? So given I depend inwards, how does a port talk to an adapter? Adapter's above it, so port can't essentially use anything in adapter. In other words, the way to think about this is port can't new anything up in adapter, right? Because it exists above. A port can new things up in the entity model, and an adapter can new things up in the port, but we can't do it the reverse way around. So what we do, at the layer of the port, which is where we want to talk to basically the database, for example, in this case, right? For example, or the messaging middleware. We really want to do that at the application layer. The application layer should really be free from those kind of concerns and just be entities. But at that layer, we can say, well, I can define an interface at my own layer, which represents the behavior I want from that other layer. And it's kind of a coarse-grained interface, right? So I'm going to say at my port layer, I'm going to wrap the database in an interface. So I'm going to create an idea like an iRepository, an IDAO, or an iEntity gateway, different kind of names, all tend to mean the same thing, right? And then what I can do is say, well, in my port, I just use that abstraction. I don't know what fulfills that abstraction. I use that abstraction. That exists at my level, so I can deal with instances of that. And at my adapter layer, I can depend upon that interface. I can implement it. And when I call into the port layer, I can provide a concrete instance of it. So at my adapter layer, I could provide a concrete repository or a concrete entity gateway that is implemented, for example, by Dapper, that wrap or entity framework that sits over my actual database, right? And then in my application service layer, my port layer, when I'm performing an operation, for example, calculate insurance premium, where essentially that workflow says, well, I need to get my actuarial tables out of the database, it calls actuarial table repository, and the adapter above that has called me provided a concrete instance of that. Okay. So that's how we effectively use what's called dependency inversion to satisfy layering requirements. That's really one of the two reasons why dependency inversion should exist for layering, or essentially because I'm using something called the open-close principle to substitute new implementations without changing a given algorithm. All right. And we tend to avoid wanting to do that just for testing purposes. I'll do that in a separate talk about TDD, but that's the real reason DI exists. Okay. And also, by the way, when you see people are also talking and saying, the same people say layers are dead, also say a repository pattern is dead. The repository pattern only exists because, like DAO before it and like Entity Gateway, I need something at my port level which is replaced with a concrete instantiation from my adapter layer later. I can't do ports and adapters style architectures without having that kind of interface usage. And that interface may be implicit in dynamic languages. Okay. Let's move on a little bit. Let's talk about domain models a bit more. So Ivor Jacobson wrote this book. I think it's pretty much out of print. You can find some secondhand copies around if you need to. And it was the book that talked a lot about object-oriented software engineering back in the 90s, I think. And it's most famous, though, for this idea of use cases. Use cases were a way of encapsulating the requirements we had for our software. So this is a typical example of a use case diagram. So here the idea is, say, some automated device that a waiter and chef and cashier can all use in order to manage orders and payments inside a restaurant, right? So I go into the restaurant as the client, and essentially my first thing I'm going to do is order some food from the waiter, who's going to type it into some kind of device. Maybe I'm going to order some wine to go with my food, right? And that order is then sent through to the chef, who then cooks the food. And when the food is ready, then essentially the waiter can serve it to me along with my wine. I then eat my food and drink my wine. Obviously, I probably don't need to use a device to do that. And when that's essentially all been consumed, I want to go to the pay for my meal, and the EPOS terminal will essentially ring up my bill, tell me how much I owe, and I can then pay for it with my card. Right? All of those use cases, order food, order wine, serve food, etc., are things that essentially describe requirements that we have for the system. And not only was this a way, and today this is really the modern equivalent. This is a user story. A user story is essentially a use case, and in fact, Alistair Coben wrote a whole book about lightweight use cases as a kind of replacement for user stories in agile techniques. And what Ivor Jacobson, the creator of use cases, wanted to do is he said, actually, I don't want to hide my use cases just in some kind of acceptance criteria file that the programmer picks up and reads through and looks and says, okay, here's the pay for food use case, here's description. I want to see that in my code. Sometimes they call this a screaming or evident architecture, the idea that I want to see in the architecture what the requirements are. So Jacobson created an architecture called boundaries, controllers, and entities. The boundary was the object that interfaces with the actor, right? So it's the thing that talks to the user. So it's the user interface on the personal device that the waiter is using to take your order. It's the screen that the chef is looking at inside the kitchen in order to basically take the order off it. It's the screen in the EPOS terminal. It's a API that we're calling for third parties to interface with our restaurant management system, etc. Right? Entities, which we mentioned before, this idea of objects representing data, right? A customer, a transaction, a cart, and the behavior associated with that data. And a controller, renamed to an interactor to avoid confusion with model view controller as a pattern. And they're objects that mediate between boundaries and entities, right? And they orchestrate the execution of commands coming from the boundary. Now, obviously, because I'm talking about it, right, you're probably going to pick up on the fact that boundaries, controllers, and entities sound an awful lot like adapters, ports, and applications, right? And this is essentially the point that Bob picks up on, this idea has been co-invented a number of times. So this is the kind of model that you get with boundaries, controllers, and entities. An actor must talk to a boundary. They can't talk direct to anything else. The boundary can't directly exercise the entity. It must go through a control object, and that control object lets you exercise the entities, right? And the idea here is that that's very similar in terms of this layered architecture. A boundary is just this infrastructure or UI layer, basically. The control objects are port layer, this service layer in our domain. And our entity layer is just basically, as we said, it's this application layer for Coben. Okay. Now, the idea was for Jacobson that the controller or the interactor will be where you'd surface this use case, right? The interactor will be what implemented the use case. So if I had a order food use case, there would be an order food controller or interactor, which represented how that work was done. So my boundary layer could call my order food use case, exercise it, and essentially, get a result that was effectively the ordering of food. And what Jacobson wanted us to do explicitly was surface those use cases, right? Say, here is a given use case called order food. I can track that from requirements into something in my code that's actually handling that, right? Something that says, this is the service layer for order food, which controls the application workflow. And interestingly enough, remembering we talked about the fact that Coben wrote a book about agile use cases as a replacement for user stories, Coben also says a port is the use case boundary. Use cases become problematic when they are focused on technology concerns. Use cases should be written against the ports to align those concerns and focus on the application rules, right? So both Coben and Jakobson are seeing this same idea of a port or a controller stroke interactor that lives over the domain, this notion of a service layer where we express the use case. And the boundary layer, which is both the inputs and outputs from us and any additional systems we may need to talk to do our work, are this kind of outside boundary. Okay. As we can clearly see, these ideas are the same. Okay. There's also an interesting, and I talk more about this one in TDD talks I do, so I mention it here for completeness, but this talk is not focused on that. The use case boundary is therefore a very useful place to do testing, because we know if we really go back and read what Kent Beck was talking about in TDD by example, what he's talking about is testing behaviors of the system expressed by a use case. Okay. And so what we can do is focus our tests on this use case boundary, our test-driven development practice. We may do automated testing elsewhere, but our TDD really is focused on these use cases. This gives us an idea effectively that our unit tests, our TDD practice, is another adapter. It is equivalent to our HTTP or GUI adapter, and it is driving our code. And it also helps us to understand what should we mock. Really, we should mock the other adapters, the things at the same level as our tests, where essentially we're receiving all these notifications, right? Because we can effectively instantiate things at that same level as us. Whereas if we test the port itself can't really instantiate those, and we have to provide them with those items. And then effectively, we don't tend to do TDD against the adapter because it's a technology concern, and we couple our test to our technology concern, which we tend to use much more test automation than TDD at that level for anything we worry may break. And integration tests we might do, I don't tend to do them so much nowadays, if we're concerned that some hookup or wire up between, say, an interface and an implementation of an adapter for, say, a database needs to work. And we system test at the boundary, right? As I said, I talk more about this in talks about TDD you can find online, so I'm going to move on slightly from that. It's more completeness here. Okay. So we've been through two of those. I'm not going to go through onion architecture because it would be more the same idea that it replicates the same principle. I don't really want to go through. There are other things out there as well. There's a thing called the use case controller pattern. The use case controller is very similar to boundary controllers and entities, but it's this idea essentially of saying, hey, I should have a controller that represents a use case. It's another co-invention. I'd even offer to you that proponents of vertical slice architecture are actually doing the same thing. It's just that they take if you think of the overall app that we're building with its boundary controller and entity layer, or its adapter port and application layer as a piece of pie, the vertical slice proponents are really taking a slice of that pie. So they're introducing some additional layer constraints which say don't cross these sidewalls of the pie, right? Everything in here just belongs to that one slice. But it's still a layered architecture, I would argue. Okay. So let's talk about the synthesis version, the clean architecture. This is essentially Bob's model of it. In the center, we have the entities. So that's basically state and behavior attached to that state, which tends to represent our business rules. Right? You can see there on the right-hand side, we're identifying that that's the enterprise business rules. Outside that, we have our use case layer, which is our application business rules, our workflow logic, right? That represents the workflow required to complete an individual use case, like order food or get insurance premium. Okay. Outside that, we have the interface adapters. And in Bob's model, he's clear that this tends to be the code we write as part of an SDK or a framework that we are integrating with over essentially the actual I/O database or HTTP web server. And the outer layer beyond that is the things we are actually talking to via that I/O. So it's just a slight clarification of that model. Okay. All right. And what that looks like a little bit is like this if we lay it out from left to right. I've got some kind of delivery mechanism, something that's bringing us in requests from a user. That talks to a boundary. That's the thing that we write is our boundary. Often the delivery mechanism is something that's basically like a framework. Delivery tends to give us a request model. It says, here's the things that you need to know about this request that came from outside. We often then turn that into something we can understand, right? Some sort of types. We use it to call our interactor. We use it to call the use case, for example, get the premium, order the food. That exercises the entities. It may also exercise other things that adapter layer, like an entity gateway to go and get, for example, the state of entities from a data store. When we've finished, we can't depend on the entity, don't forget, for directly from the boundary. So we have to return a response value in some form of response model. All right. Two things in gray are data structures. In other words, they tend to be things that have state but not behavior. Things in yellow tend to be classes, things that have both state and behavior. Things in green tend to be basically either interface in the form of entity gateway or some concretized version of interface in the form of boundary. Okay. So, for example, for a ASP.NET Web API, we've got the framework, effectively Web API, on the outside. We write the controller in green, which effectively then plugs in, and the API framework says, I will route given requests to your controller. And essentially, it lets you effectively bind a model which says, hey, the parameters basically of the HTTP request, the query string, the body of the request can get turned by me into something that forms a request model to you. Your controller should then call an interactor, something that represents the use case, right? Next layer down, which then essentially in turn exercises the entities. When it may need to talk to something like an entity gateway in order to get their data out, and in return it returns a response model. Okay. MVC, if it exists, for example, exists at this outer layer. Your response model is essentially your view model, and any presenter which basically effectively generates a view exists at this outer layer where I'm, for example, generating some kind of JSON representation of the response I'm giving you at this point. We mention that mainly to avoid confusion that somehow the interactor is the MVC controller. It isn't. All right. And the entity gateway we can see is essentially talking to our database. So what is that interactor? How would we model that? So one typical way we tend to think about modeling interactor is the command pattern. Command pattern is quite often associated with a use case. Commands are seen as a transaction that we want to run in the system quite often. They're good transactional boundaries. And use cases are often seen as transactions. We mean business transaction there rather than necessarily database transaction, because it may have more work steps than you'd actually want to hold a database transaction for, right? And the idea behind the command is I give it some parameters in its constructor. I call execute on it from the client, and it in turn then says I'm going to exercise a given receiver, in other words, an entity, and call some methods on it, all right? The command line pattern is very interesting, right? The way I tend to implement that is I say, here is my interface. I am a command with an execute method on it, and I can go away and create something that says, when I call execute on you, go away and do something on my entities. Sometimes folks like to have a query as well, which says I am a query and says, query stuff that actually returns a value, right? So in this case, command doesn't return a value because with commands mutate state but don't effectively return state, and queries return state but don't mutate it. Sometimes folks like to have a corresponding query object. It's really the command pattern as well. but it just says it returns a value and doesn't mutate it. Okay. So you can have a model that looks like this that says my interact is just a command. That command effectively contains my application or workflow logic, which drives the entities and talks, for example, to my entity gateway. All right. There's also a notion called a command dispatcher, right? And a command dispatcher says I could actually parcel up the parameters into a command, the things that vary, and separate that from the thing that actually executes my domain model, the handler. And I could use a dispatcher to route commands to handlers. So this model here, you can see essentially I have a command. The command essentially is registered with a command dispatcher as being serviced by a handler. The concrete command handler essentially, when I send the command to it, will effectively call my domain model and execute actions against my entities. Why is that useful? That's useful because I can I can create basically a pipeline, sometimes thought of as a command processor model of arbitrary steps between essentially the sender and the receiver of the action. And that means I can move orthogonal operations like logging or retry an event of failure using something like poly out into some middleware that separates my domain, clearly running in my application logic in my handler, from these orthogonal concerns, which are more to do with things like reliability and observability and monitoring. Right? Okay. Let me show you some code so you can kind of see how that works. By the way, where Brighter steps in is Brighter effectively gives you that dispatcher model. Okay, so I'm going to stop sharing this and share Rider instead. All right, let me share this. Hopefully you can see that. This project is on my GitHub. My GitHub is just Ian Cooper. And it's CA-tutorial is the name that you can see in the top left there is the name of the project on GitHub. So you can grab this yourself. Okay, so the idea with this is there are a series of branches, and each of the branches represents transformations of this project. Right.
Ian,
yep.
could you zoom in a little bit?
Can I zoom in a little bit more? Yeah, for sure. I can stick it into presentation mode and make it really big. Tell me if that's too big. All right. Oh, it's made that big. Let me reduce the size of that a bit. Let's see what it's done. Okay. Is that too big or is that good?
Looks good for me.
Okay. Excellent. All right. So just a word about the application you'll find in here. The application in here is the world's most overcomplicated Hello World system application, right? And what it does essentially is it lets you create greetings, post them to a server for storage, and then retrieve them later. Okay. It is, as like all demo code, the idea is to remove from you the complexity of an actual domain so you can focus on the work we are doing in terms of the structure of the code and its architecture. It has the problem as a result that it is much too simple a problem space to really be using any of this complexity on, right? So imagine, if you will, that when we look at this and you see pretty much a CRUD-based set of operations, that there really is a complex domain model here. The problem with doing a demo and showing you all that is we would get lost in how we do premium calculations for smokers for life insurance and not focus on the actual structure of the code, what we want to do. Okay, but I'll show this working briefly. So I can go and get essentially all the current set of greetings. Rider does this for you. It lets you run against an HTTP file. Visual Code has a similar thing if you use something called REST API, I think, or effectively. Okay, so then you can post a new one, right? And instead of down the bottom, it will return after that post. It'll say, okay, you've created this new message called Hello Mary. So I can go and get all my greetings again, and now I should have a Hello Mary in there. Oh, illegal character and path. I wonder what happened there. Let's try doing it there instead. Let's see what happens. All right, what happened there? That error was from Rider itself because it said Java, and I haven't written any Java. Okay, we can post another message, and we can go and get all the messages again. And you can get individual messages, etc. It's not very relevant to this talk to that too much. You can play with that. There's a Docker file which generates the relevant pieces of infrastructure you need to get that working if you want to Docker compose file. All right. So look at the application. That's really why we're here. So my greetings app is just essentially a classic web API application. Here's my controller. Okay. And what I've done in this initial phase is in the actual controller methods that represent my different HTTP verbs, my post, my get, etc. I've just got all the code, right? About the only level of abstraction we've got is we wrap essentially our greeting context around our DB context slightly, but that essentially is just saying here, go and create an entity framework context, go and get all of the greetings for it, then turn them into this greeting by ID result and display that out. Here it's basically saying post, skip all this console write line stuff for the minute. It's just confusing. Here we're going to go and create a greeting repository. So this is going to wrap basically our greeting context just so we can do things like add async. And we're going to add basically essentially a new greeting in, right? And delete. None of this code should be particularly rocket science as far as anyone's concerned. Just using entity framework, wrapping entity framework slightly to make my life a bit easier. So that's just basically saying, hey, don't forget to call things like save changes in. Don't forget to do stuff like remove stuff, right? Very simple kind of wrapper. Okay. It's a bit horrible because all this code is inlined in the controller. It's difficult to get under test. I could test basically my controller, spin that up. I don't like to do that because I'm then mapping my tests over a technology concern and what happens if I want to change the way I do this. Or I want to use a different type of interface, like a razor page directly to my use case. So I don't particularly like this model. So what happens if I want to change the repository that I'm in? Well, that's interesting. I'm going to do that off screen because now I've made my screen big. I've lost the ability to easily do that from Rider. But let me just, I can do that in the background of the terminal window, so you'll never see what I'm doing. So what I'm going to do is I'm going to switch the repository that I'm using to another one that has the kind of the next stage. So I'm going to do this one. Right. So what I do here is I say, let's create a facade. So let's introduce layers. All right. And in this layer, what I'm going to have is something that basically does the controls my application workflow logic around greetings. So I'm going to simplify controller quite a bit, right? It has a greeting facade. It just says on a get, it says go away and get all of them, right? Or get one of them. And it says on post, it says, okay, add one. And then this thing that with console was doing this regreet. So in other words, broadcast that greeting out to the console, all right? And I can say get it, I add one, and then I get it, right? So here we've got quite a strict interpretation of the command model. We're saying I create one, it's got an ID, I can retrieve it later, right? And that gives us also basically that's greeting by ID result. It gives us a response model back. It's different to the one we write originally. Okay. So in some ways, you've got an early step towards our clean architecture. We've got basically this facade model that represents effectively like our interactor. We've got a repository which represents effectively another kind of interactor, and inside we've got some kind of entity model inside. All right. So if we go and look at that, all right, we inject in our DB context, but here we're saying stuff like it's clearest perhaps in something like the post Add async, yeah, we're going to go away and say, hey, create a new greeting. So create a new entity and add that to the repository, right? And imagine we had some really more complex domain logic in there than just instantiating a greeting, okay? But we're exercising the entity model direct, and that's not being accessed anymore directly from our adapter layer above us. So we've kind of got that beginnings of this model. And we return, for example, a response model. So that's not the same as our entity model. We don't return our greeting. We return a greetings or result. And we take in a request model, right? So this GUID ID and the string message. We don't take in a greeting. We take in this a request model. One of the things you'll see quite commonly is kind of facade layers is, primitives actually come in and go back out again, more data structures, right? All right. That's all right. It simplified things a little bit. But I do have this big greeting facade class that potentially, if I had real domain logic and application workflow logic here, is I'm just putting all of my use cases in one file, right? And maybe that's not the right thing to do. Maybe actually be better if I split up my use cases into a number of different files so I could see each one of them individually. And that would also help me with things like reasoning about the software. I only have to look at one use case, and even testing. I'm testing an individual use case rather than this whole big thing. So let me just check out that branch. All right, and we should let this thing draw, I think, in a second. Controls. Okay. Oops, have I done that? Did not match in. What have I spelled wrong? With. Okay. All right, there we go. Let's get back in here. Okay. So here, now rather than having this one facade, we have a number of different services. I've got this greetings all service. So the use case I'm looking back is get me all the greetings. And it's got a query async and it turns my response model. I've got a greetings by ID. I've got a use case to get me greetings by ID. And essentially that's going to return to me a response model when it executes query async. Great. I've got this use case for add greetings, right? Great. And I can actually begin to see, I can see clearly I'm reusing this greeting by ID use case. That's a common pattern, basically, in use cases. You get these small use cases that get reused by larger use cases. So I'm beginning to see that idea emerge, right? And I've got regreet service for a use case. And delete greeting basically is a use case. So all these things become use cases that I can now use. Excellent. So I've surfaced this idea a bit more that I've got these individualized use cases that I may choose to deal with. And I can go and look at one of those use cases and see that I've got basically information around that. And I'm not going to pull in any dependencies that are unnecessary for my individualized use case. It's nice and clean, and I've probably simplified things. I can reason about this as being an individualized use case. All right. And I look at this and I go, well, that's very interesting. But actually, this is just a variation of a pattern that I know exists, right? So having kind of proved that, I'm not going to be pattern happy if what I then do is say, you know what? That's actually an existing kind of pattern that I want to use. And that's basically to use the command pattern. All right. So now I can see that maybe these things are commands, right? So when I look at add greeting, it's essentially saying I am a command, and it has an execute async method, right? And it's saying, okay, all of my commands look similar, right? They're effectively just asynchronously go and execute what I want. And I've effectively got this nice simple model saying greeting command execute async. And to be honest with you, when you begin to move towards clean architectures, something like this is a reasonably good place to be, right? You've got distinct commands, and you also have these things that are queries. Queries differ because essentially they have a response that they're returning. An IAM command could be IAM command of type T, right? And could actually take your request model in. We don't show that here for some reason. I can't really recall. My bad. But IAM query here is saying I return this response model, and IAM a command could take in a request model. Now, actually, then I got pretty close to being a basic clean architecture. Okay.
Ian, we have got one question. What do we do if the add greeting service requires the get greeting service?
Right. So, generally speaking, it would be most likely that your reuse would be the controller saying, "Hey, I want to add something, and then I want to basically." Was that question regreet, or question was basically greetings by ID? Can you repeat that question again?
What do we do if add greeting service requires get greeting service?
Okay.
So if you have
So
dependencies
I would
between.
tend to not necessarily reuse that inside, right? I would tend to just re-implement that and add greeting in case the two are quite different. If I want to get a greeting, like if I had a modify an update greeting command and I wanted to go and get hold of an existing greeting, I would probably just use a DB context to do that directly against the repository, rather than effectively reusing the actual use case. The use case is over my entity model. I can reuse the entity model in different use cases. So I would reuse at that level inside rather than reusing at the use case level. Okay. Good question, though. All right. So why might I want to go further than that model? All right. And that's not, you could definitely go there and be and say, I'm going to sit back, I've got a nice clean architecture. All right. So why might I want to do something else? Well, what we'll show you here is when we want to go to handlers for something like Brighter, what we're looking for is to support orthogonal operations. So here, the add greeting command, rather than calling an execute method on it directly, right? What we're actually going to do is hand it to a dispatcher effectively by calling it send async and say, find something that essentially is going to basically implement that for me. Okay. And so here, what I end up with is some ports or interactors. The command is essentially defined at this level because the outside can then create an instance of it and send it to me. But the handler effectively is my port. Okay. And while this port mostly looks like the execute method for my command, right? It's basically saying effectively I've got a handle method that returns. It's returning an add greeting command because it's a chain. I'll come back to that in a second. It's just in the same operation of creating my greeting and saving it, right? So I'm reusing the entity model, I'm using my repository model, etc. What we have here are these attributes. And these attributes represent reliability concerns that I want to essentially wrap this handler in. Okay. And what we're using Brighter here to do is to say, I want to put some middleware between the controller here, when it's essentially saying, execute my add greeting command, and the handler here, when I actually perform the domain logic that I want. And I want to do a number of things. The first thing I want to do is log that I'm calling this handler, right? Ignore the handler timing, it's a bit historic, effectively. And I want to essentially wrap this in a thing called a policy. And it says I'm doing a retry and a break circuit. What's going on here? Well, I'll explain that to you. It's using poly as part of its middleware pipeline. And it's saying, invoke a poly policy. So what we do is we have a policy registry, and this refers to a policy in the policy registry, retry policy async or circuit breaker async. Go and find that policy and execute that policy, wrapping later steps in that policy. So what this says is if I handle async fails, I have a retry policy. Now, if there's a database error, what I may be able to do is retry it, maybe a transient error. So essentially that policy which I've set up elsewhere says, okay, in the event you get a database error, retry that error, and then retry it at a certain interval. You may say, hey, if I get a certain number of database failures, I want to stop talking to the database because it's just going to keep failing and generating errors, and it's going to put additional load on the DB. So I'll break the circuit, and essentially I'll only let one in every so often now. Otherwise, I just fail them. And when I get one that I let through, I'll see if it basically passes, and if so, I'll close the circuit again. Right? And request logging async that sits outside that and just says, hey, if you get as far as me, log. All right. So it's an interesting way of us moving away from that problem space. The other thing we're showing here, by the way, is that we can publish async. So what we're doing here is we're saying, well, actually we've got in the controller, we're sending a command saying, go and do the work. But notice the regreets move from here. What we're doing, our greeting command handler says, when I've completed that transaction, another part of my execution pipeline wants to do something in a separate transaction. It wants to know that that happened, and it wants to basically issue a regreet. So we can also effectively say, take that bit of work out and do it again somewhere else. And that could, because it's an event, there could be multiple things listing to that. So I could have multiple handlers which respond to the fact that I've written something to take new action. Okay. So we can effectively get a pub sub model, but it's all at this point in memory to our application. Now, it's not really the objective tonight to talk too much about this next step, but what we can do with Brighter simply is to say effectively, I want to switch this to, well, I'm just trying to catch up, a post rather than a publish async, right? And in Brighter, that means send this over some message-oriented middleware rather than sending it over an internal in-memory bus. To send this over RabbitMQ or Azure or SQS, something like that, because the person implementing this particular operation is out of process. Okay. I don't know why, by the way, I switched it to command in this particular instance. It's not relevant to this conversation. I can't remember why I changed it from an event to a command. It probably should be an event. All right, and that goes to a worker. And actually, all we're doing really with workers, we have the same handler that we'd actually run in the previous context, but now we're effectively putting it in a separate process. And that separate process essentially is able to effectively run that. And this is slightly more complicated version. It's an older configuration model before we fully integrated to host builder. So I'll show you in a second integration to host builder. Okay, to that Brighter. And that's kind of how Brighter is supporting this interaction model. Let me get through the slides and I'll just show you a little bit more of Brighter in a second. So what I'll show you in a little bit is the samples that come with Brighter, so you can go and review those for yourself and see a couple of things that we do. All right. Okay, actually that's the end of those slides, so I've just showed Brighter instead. I'd forgotten that was the end, right? All right. I forget that's the end every single time, so I don't quite know why I shouldn't remember that. Okay, let's share this version. This thing. Okay. So this is the code base of Brighter, which you can find at GitHub under Brighter command, right? That's why my bio says the Brighter command is basically that's a Twitter account we use for this app. Okay, ignoring the left, you can see Brighter is divided up. So there are two key things to Brighter. Brighter here, paramod.brighter, it's all NuGet packages you can get, is essentially this command processor. So it says, I will take a command, I will dispatch it to a handler, and I will let you put middleware in between. And we define some off-the-shelf middleware for you, logging and integration with Poly for middleware, okay, and some other messaging-related pieces. And then most of the rest of this stuff is actually to do with messaging, okay? Ignore Sidecar for the minute, something I'm working on that's new. But service activator here is essentially a message pump that says I can consume messages off a piece of message-oriented middleware. And when I get that message, I will translate it into something from it, whatever it is, JSON format, into something in your type system. I will assume that thing in your type system is actually a command or an event. And then I will use the Brighter command processor to dispatch that to a handler. That's how we're able to say, hey, I can take that same handler, I can use it in process with a publish event, and I can use it out of process with a post. Okay. And then really much of what the rest of this is a whole set of support for different middleware, right? So different middleware, Kafka, AWS, Azure. The Azure one is not really production grade. People keep taking it and forking it, making it production grade. Please be the person that submits it back to us. We don't really want to have, we want to have one that's actually got battle tested, because all the rest are battle tested. Redis, there's a new Redis one coming that relies on streams. RESTMS, don't worry about. That's a spec we implemented that is not much in use today. RabbitMQ is the big one. an AWS and kind of Kafka. And then basically there's a thing called inbox and outbox. I don't want to get into that today. Inbox is essentially I'm storing a copy of the message I'm about to send that's been sent to me so I can do deduplication. And outbox is I'm sending a copy of messages I send in order to make sure that if there's a send failure, I can guarantee I will send it at some point in the future. Right? We just support different databases for use in that context. All right. More useful to you at this point is the samples are quite handy. So there's a very basic model, which is just to do hello world, right? I'll show you the async and the sync version, just similar sync and async, right? And you probably never be able to write anything quite this simple, right? But we now work with kind of host builder stuff. So service collection obviously is the default inbuilt version control container now with SP.NET, so we work with that. And we have a model to say, very simply, add brighter auto from assemblies. What we mean by that is add the command processor, go away to your assemblies, find all of the handlers that you have, and then register them basically so that you can dispatch the commands they take to those handlers. We do that registration for you up front, so you don't have to go and register anything manually. In the CA tutorial, when you look at that, you'll see we're doing manual registration. That's because that example was written before we'd actually got the host builder support in. Here, because we're using service provider outside of host builder, right? We're just trying to be very simple here. We're not even bothering to use host builder. We just have to build our service provider, and then we go and get our command processor out. If you're using something like host, we don't have to do that. And then we're showing a simple send this command. And what that will do, that new greeting command here, with the greeting command handler, is just essentially print hello world. This one, I think I could probably just execute for you at the terminal. So let's see if I can run this one, because it doesn't require too many running parts. Run hello world. That should just print hello world at the console. Build that project. I haven't tested this, so the demo gods should be hopefully kind to me. Yeah. So you can see essentially, not only did you get hello Ian there, but you got a lot of additional information being pumped out, right? It said building a pipeline, new handler pipeline created, tracking instances, basically, etc. All of this stuff, which is basically we're logging at quite a verbose level here, is stuff that's either provided to you by Brighter's framework or because we had the request logging attribute on the handler. So the request logging attribute on the handler is what's essentially saying here, logging handler pipeline call, right? This is basically what we're receiving. It's saying passing the request to this step. So it's showing you the pipeline steps. You do the work, and then it's basically going back out again, right? So we support what's called a Russian doll model. The Russian doll model means that each step encompasses the next step. What that means is you can effectively write a try-catch block, which says, try, do this, call the next step, catch any errors that occurred down from it. That's how we're able to use poly, because we can effectively say we wrap later steps inside our poly policy. Right. And there's essentially, obviously, an async version of the same, an async example here. I haven't run this one for ages, so let's see what happens if I try running this one. Demo gods have been kind so far. There's some stuff to change the console output color, so that may look horrible in Rider. I don't want to guarantee that. Okay. Oops. Yeah. All right. So we're showing stuff around exceptions. For example, we're saying want to be greeted, which is the command. We're then essentially saying, okay, depending on what basically the event is, we can simulate some throwing exceptions to show how they work, etc. Exceptions effectively can get caught by other steps and then effectively kind of logged out basically for you. All right. So we'll see those, and we're also, I believe, yeah, this is basically want to be greeted to. I want to be greeted 2 comes because I believe program does that. Start async down here. Try publish async, a new greeting event for Devil, right? And we have one up here which publishes a new greeting event with Roger, which are at 2. And I believe that this, let me do it this way. All right. So basically, because we're publishing an event here, we get to both of these. So you can see that because we used an event to publish, and greeting event is an event handler, we will get both the call from want to be greeted, which essentially has got these argument exceptions and want to be greeted to, right? Which is essentially doing different work. So we've got want to be greeted up here somewhere, I suspect, is receiving the request, right? And we've got want to be greeted to receiving the request. And then we're going to get basically effectively these built-in comments on exception handling. All right. Now, final thing I'll show you before we close down, that you can look at these examples yourselves for more information, is RabbitMQ. So RabbitMQ, essentially what we've got here is a sender and receiver. This is the shared library. You can see in the program here, what we're doing is doing slightly more work to just configure RabbitMQ, right? So what we're doing is create a connection, and that says, where do we find the RabbitMQ broker? What is the name of exchange you want to use, basically? So exchange is a primitive in RabbitMQ, where effectively a routing table, if you think the way to think about it. We're saying create a producer. That's how we send stuff, right? Then we say add writer, which is basically adding effectively all those handlers, but we're doing for assembly, but we're now configuring some things. Outbox, the copy messages that we sent, just going to use something in memory to hold them. And we're effectively then configuring all of our messaging, right? And then we can basically do the same thing, build service provider, get service. We can post a couple of messages as part of the test. And in theory, what happens is they get handled by the receiver, and the receiver similarly sets up a thing called a connection, which essentially is a queue it wants to listen to from Rabbit. So it's saying, go to this exchange, listen to this routing key, call it this. As again, a Rabbit primitives basically effectively dealing with, gives you some information about that Rabbit uses to configure its queues, and then essentially says, similarly, go to our assemblies, find all the handlers, and here's how we want to configure the messaging. It's a bit more complicated than the vanilla one, because now we're dealing with messaging middleware that needs to be configured, and then we just run this host async, and that runs the message pump, and then it will go away and listen for events. Okay, I can try running that. I've not run this one for a while. Let's just see whether I'm going to push the demo gods too far to see if I can run that one. I need to basically switch to terminal to try and run that. I'm fully expecting at this point it will go run this demo as a practice. Let me make that a bit bigger. You probably can't read any of that. Okay, and that one. Whoops. I'll clear this side. Right. In theory, what I want to run is I want to run the server, so I'm going to go in there and do .NET run. If that runs, we should have something listening for messages. And what it will do is essentially set up the relevant queues on Rabbit. So if this bit works, which I'm not necessarily seeing promising signs of yet because it's not doing anything, but maybe it's just got no output yet. All right, let's assume maybe it's worked. Oh, there we go. So there's a slight problem talking to Rabbit by the looks of it. All right. So hang on, let me just see if I'm running Rabbit on Docker. I am running Rabbit, it says to me. No, I'm not running Rabbit for some reason. All right. Let me just probably, Interestingly, can you see those circuit broken messages? That's to do with us reporting effectively that we can't get to rabbit. I will try once more, just because I might be able to get rabbit running from a different place. See if I can get rabbit to spin up for us. Okay, let me see. All right, I should have a rabbit, I think. Let's try that. And we come in lots of documentation. So if you go to that site, you'll find links to read the docs site that we use to document Brighter command. We are pretty heavily documented. And we also have a kind of like page that basically sets up. So for some reason, I knew there'd be a mistake to try and run this one. Oh, no, I'm actually getting messages, I think. Here we go. So I should have a working queue. Can you see down the bottom? It's now talking about trying to prepare to receive messages. So in theory, if I go to the right sample, queue request, apply examples, and I look for the sender. I'm moving your face out of the way, my friend. Right, and I do .NET run here. I ought to send a message that will get picked up on the far side. I'll probably put it at the bottom of the screen, as is always the way when you have something that's doing that, right? But can you see we are essentially sent a message and received that message, an acknowledging message. You can probably see it scrolling up the screen, right? Okay, awesome. So proof effectively that you can go into that example and get it working. We do provide a Docker Compose file in Brighter that lets you run everything that would ever be needed by any of the transports and pieces of middleware, right? And that's only for QA purposes. If you run that, it will chew up a huge amount of memory in your machine. What you may want to do is take that Docker Compose file and trim it down to just the bits you need in order to run whatever examples you want to run. Or, unlike me, you have a machine with vast amounts of memory and you don't care, which is fine. One of the things in there is SQL Server, which will chew up 4 gigabytes of memory just for starting up. So I would suggest you're cautious around that one. All right, that's me done, I believe.
Cool. Ian, we have some questions from the chat.
Okay.
The first one, would you share the slides?
The slides are in, you go to GitHub, go to Ian Cooper. There's a folder called presentations. All of my slides from anything I do always go in there. Even the commercial workshops that I run, that you pay money for, like practical messaging, the slides are all in there. You can go and have a look if you don't want to pay for the course.
Cool. Good. I posted the URL to the repository. But the next question was from Nautic. Where would you put authorization logic? Like this role is not allowed, but that role is. Is that application logic to you?
That's a good question. I would one of the dangers with anything that's basically like orthogonal stuff that say we can do Brighter is don't ever put domain stuff in there, right? Because really that's for things like logging, reliability, monitoring and observability, stuff that clouds your domain. If you have some authorization that says, is this user allowed to run this to do this thing? That to me is part of your domain. Now, it's probably potentially part of your application workflow logic. So you could certainly have some part of your handler that says, hey, I'm going to go away and call this thing that does that work for me to figure out that basically whether the user can do that thing. But what it's calling, it may depend. It may actually be something that's inside your domain that figures that out already. So you may be just calling one of the things in your domain model, or it could be an external thing, in which case it's basically calling out over a port. But probably to say that kind of steps like validate a user could do this, I would put that in the handler as part of my application workflow logic, rather than what I may exercise from there might be entities, right? Depending on how you do your authorization.
Cool. Thanks for that. And the last one, it's a little bit longer. So where it is? It's a comment from Lemming Fury. He excuses because of giving a negative comments. His feeling is it's such a way of solving the problem of increasing complexity, exactly why some devs hate their job. Ideally, you want to reduce the complexity by adding invisible, transparent abstractions, removing certain aspects of a problem domain as a whole. And here it's more like you're breaking the problem to a number of pieces, but the breakage itself makes it look simpler only because the pieces are getting smaller.
Okay, I think I understand the question. All right, so it's a question of a simplification, right? And the question is when would you do that simplification? And for sure, certainly in the example we use of the greetings project, it's such a trivial domain that we are adding complexity, which is way beyond what that needs. And that's absolutely true. I would tend to move up in layers, right? If I didn't have use cases that I could identify when I began to look at what I was doing, that seemed like there were an actual meaty use case, it's probably not worth going to a command model, right? If I go to a command model, it may be worth me going to a dispatcher model if I have any reliability concerns that are important to me that I want to remove from my domain that are cross-cutting, right? And that second jump can be quite fast. As soon as you want to do things like log all your commands, introduce basically centralized error handling around certain types of failures, then you can rapidly get to the point where it's useful to do that. Our model actually is to try and be relatively straightforward in that the handler you write, we don't believe is significantly more complex than, say, an ASP.NET controller. And the reason we use things like attributes and we don't tend to favor, say, as mass transit, which another alternative does, fluent syntax around building your pipelines in the same way. I mean, we could do that. We just never demand for it. It's because we want to emphasize, I think, that the simplicity of the handler. And particularly when you come to do messaging middleware, we are taking a huge amount of complexity away from you. You don't have to understand how to work with a given transport, how to run a message pump. I mean, we do stuff like test RabbitMQ with Blockade, which is a tool which is very similar to Jepsen. We simulate failures on nodes in Rabbit to determine what happens and what the errors are and how we make you reliably reconnect, etc. to that. So we remove a huge amount of complexity from you. But yeah, I mean, I'd always say I'd agree with you, right? I'd agree with you. Don't add this extra complexity unless it's actually reducing the overall complexity. And if you feel that the simplest solution to your problem right now is at the controller layer, sure, just do that, right? It's an OSS project, right? And it's the way I prefer to work, but I don't make any money from you doing it either way. So I find it very useful. I find it very useful to be able to test my handlers as my application workflow logic directly. I don't tend to exercise the pipeline most of the time. I wouldn't send the command process. I just directly call my handler and then execute that logic. I assume that the orthogonal steps have got their own tests around them, and that enables me to just focus on testing my domain logic. And then once I've got my tested domain logic, I can then assemble that whole pipeline. But yeah, hopefully that's a reasonable response. But yeah, I mean, everybody's layer on what is simpler and what is actually harder differs, right?
Good. Thanks for this elaborate answer. Ah, yeah, Lemming Fury respond. Yes, that's a good response. Good. Good. One last question from chat is how much overhead is Brighter adding over a direct RabbitMQ publish handle? Do you have some performance numbers?
We wouldn't have any numbers on what the overhead is. Uh, in a sense, I mean, I teach a course in messaging, right? One of the things I teach in that is how to build your own equivalent of Brighter, right? It isn't actually Brighter, but it's a very lightweight exercise. It doesn't have any really much error handling logic in it. The thing is, if you want to use RabbitMQ doesn't come with an SDK that gives you a message pump, so you're going to have to write one, right? Do you know how to write message pump, right? Do you know how to write message pumps with basically use threads sensibly and let you throttle, apply back pressure? Do you understand what RabbitMQ's failure conditions are? That's what we're really dealing with. The overhead, if there is some, it really comes from the command processor doing a dispatch to a given handler pipeline. There's an overhead the first time you run a pipeline because it uses RTTI to build the pipeline. Once you build a pipeline once, then essentially we cache that and we don't force you to figure out the pipeline in future instances. So at that point, it's relatively low cost. So it doesn't add an enormous amount of overhead, particularly in a kind of world of messaging.
Cool. Good. So this was the last question from chat. No new ones were added yet.
So I'm iCooper on Twitter, and my DMs are open. And so if you think about a question in the next couple of days, or you go and have a look at Brighter, and you're like, I really don't understand how this works, someone can tell me. You can always DM me, right? And I will respond to that. It might take me half a day or so before I realize that Twitter's giving me this. Basically, someone wants to send you a message thing, but eventually I'll notice it, right? But yeah,
Good.
we'll try and be as helpful as we can if you want to use it.
Good. Thanks for the offer, Ian. I posted your Twitter URL in the chat,
Right.
so everybody has it. Good. Then I'll take over again. Okay.
Yeah, all yours.
Good. Then thanks, Ian, for this wonderful talk. What every speaker at our meetups gets is one of our custom coasters, self-made.
Wow.
So I will get one of these to you.
That's good because I'm using this piece of mail paper as a coaster currently right now, so I could definitely do with a coaster.
Okay, I think I will send you them too. Good. Yeah. Thank you. Thanks to you all for joining. Was nice to have you here. Thanks again to our sponsors, Theater Every, Rubicon, and JetBrains. And if your company or you want to sponsor us, talk with us. We have some general information about sponsoring on our website. These are suggestions, so we are ready to talk. Next plans for the next meetups, we have every month a meetup. November will be probably about .NET 5, C# 9 related. You all know .NET Conf is coming, and with that .NET 5, the .NET 5 release. Good. If you want to hear some topics in future meetups, please create an issue in our GitHub repo for the GitHub repo, and we will then look if we can find a speaker for this topic. We want to present cool, interesting stuff to you, and for that we need to know what you're interested into. And where's my mouse? So, and one thing would be cool if you spread the word that we are here, invite colleagues to the next meetups, invite friends, customers, tweet retweet our stuff, invite everybody that has to do something with .NET, that we're able to spread more knowledge and experience about .NET. Once again, all our links where we are represented. I don't with the horn again, return again. So, and the last one, we always want to improve the meetup. So we have a short feedback form. If you could fill this out, it would help us. At the end, you can put your there is the option to be part of the raffle of the JetBrains license, and you have until Friday to fill it out, and over the weekend I will send out the license code for the lucky winner. Yeah, and that was it. See you all in November. Ian, to you, there are some thanks from the chat for the great talk you gave.
Thanks all. Thanks very much for having me. It's nice to be able to reach out.
Yes, and yeah, thanks for being our today's speaker. So, have all a nice rest of your day. For some of it's really late, for some probably early. Still, so have a nice day, and yeah, see you in November. Bye.
Bye.